Our week 9 topic is about calculating the percent yield. So the amount of product a limiting reactant produces is known as the theoretical yield of the product. But theoretical yield is not always achieved because of certain factors such as side reactions and different conditions. Percent yield is the actual yield of the product over the theoretical yield multiplied by 100. So to fully understand the lesson, remember the formula of the percent yield. So percent yield is equal to the actual yield over the theoretical yield times 100. So before we obtain the percent yield, we are going to have different calculations. So identifying the molar mass, the limiting reactants, and the excess reactants. So we have our sample problem. Our first problem, if 15 grams of MgO is treated with 18.5 grams of H3PO4 and 17.6 grams of Mg3PO4-2 is obtained, calculate the percent yield and excess reagent in grams. Okay, our first step is the equation. So before we proceed to the calculation, we must balance the given equation. So we have magnesium, oxygen, hydrogen, and phosphorus. So we have 1 in this side, and in this side we have 5. Our hydrogen is 3, and our phosphorus is 1. So the value of magnesium in the product side is 3. Oxygen is 9. Hydrogen is 2. And P is 2 because 1 times 2. Okay? Let us think of a number that will balance the equation. So let us put 3. So 3 times 1 is 3. So we will get the value of 11 oxygen. Then put 2. We have 6. Then 2. So on the other side, let us add 3. So we obtain 6. Then 11. Because 9 plus 2 is 11. 6 plus 3. Okay. So since balance na siya, let us go with the step 2. It is identifying the limiting reactant and the excess reactant. Okay? So the given, we have 15 grams of MgO, so 2 the product. Okay? Stoichiometry again, 40 grams of MgO is the molar mass, is to 1 mole of MgO. So in the equation, you have 3 moles of MgO. So 3 moles of MgO to 1 mole of Mg3PO4-2. Then, perform the operation. So cancel. So 15 times 1 times 1, 15 divided by 40 times 3 will obtain the answer of 0.125 mole of Mg3PO4-2 or 0.13 kasi 5 na yung nandun. So mag-a-add ka ng isa. 0.13 mole of Mg3PO4 2. So next reactant is the H3PO4. In the given, we have 18.5 grams H3PO4. So the molar mass of the given compound is 98 grams. PO4 is to 1 mole of H3PO4. Now, let us get back to the equation. We have 2 moles of H3PO4 to 1 mole of Mg3PO4 2. Solve. So, cancel out the same units. Then, solve. We'll obtain the answer of 0.094 mole or 0.09 mole of Mg3PO4 2. Now, we are going to identify which is the limiting and the excess reactant. So, since 0.9 or 0.094 is a smaller value than 0.125, therefore, H3PO4 is our limiting reactant. Then, MgO is our excess reactant. Next is the step 3. The mass of the limiting reactant to the mass of the product. So let us solve. So our limiting reactant is 18.5 grams of H3PO4. So 98 grams of H3PO4 is to 1 mole of H3PO4. So to the equation, we have 2 moles of H3PO4 and 1 mole of Mg3PO4 2. So 1 mole of Mg3PO4 2 is to 262 grams of Mg3PO4 2. So cancel out the same units. Then we will obtain the answer of 24.73 grams of Mg3PO4 2. So this value will be our theoretical yield. So step 4 is calculating the percent yield. So our formula, AY over TY times 100. So in our problem, we have the actual yield of 17.6. Then our theoretical yield is 24.73 times 100. So perform the required operation, then we will obtain the answer of 71.17% or 71%. So this is the value of our percent yield. Our second example, calculate the percent yield of the reaction if the theoretical yield is 8.50 grams with an actual yield of 7.35 grams. So just substitute it with the formula, 7.35 divided by 8.50 times 100. So we will obtain the answer of 86.47%. So it is our percent yield. So that's all for today. Goodbye.